Right. Now, moving on to the next question. Yes, in question 6, we have a split function or a piecewise function. Right. We have a piecewise function where f of x is equal to minus 0.5x plus 1, which is represented by this piece here less than minus 4. Right. So this is negative 0.5x plus 1 at 4. At x is equal to minus 4, we have 5. And then at x plus 7, we have minus 4. So between minus 4 and 1, we have x plus 7. There's your x plus 7 here. You just write it here. That's x plus 7. That's negative 0.5x plus 1. This is just 5, the value of 5 at x is equal to minus 4. And then between 1 and 3, we have a quadratic function which is negative 0.5x squared plus 6 piecewise. And then we have ax plus b, a linear function continuing from x greater than 3. After this, we have ax plus b. Perfect. Now, let us solve this question here. So the first question is asking us for identify by means of their coordinates any points of discontinuity. Right, identify by means of their coordinates any points of discontinuity. You should also classify the discontinuity and justify your classifications mathematically. Pay careful attention to notation. So my first, by means of their x coordinates, so we're looking for the x coordinate where it is discontinuous. So I can clearly see a discontinuity at, we can clearly see a discontinuity at, in the graph at 1. And this type of discontinuity is a jump. And I can see another jump discontinuity here. Jump discontinuity at minus 4, at x is equal to minus 4. So let us solve this. So at x is equal to 3, so 6.1 at x is equal to 3, right? Limit at, as x approaches 3 from the left. So let me just draw 3 here. This is from the left and thus from the right. So limit as x approaches 3 from the right of f of x, which is the entire function, is equal to x approaches 3 from, sorry, not 3, should be 1. Limit as x approaches 1, not 3, because we said at 1 there is a discontinuity here. At 1, at 1. Right, so going back again. Right, so limit as x approaches 1 from the right, you can see it's touching this graph, which is equal to approximately 5.5, or if you substitute 1 in this function, I'm getting negative 0.5 plus 6. So what I'm getting here is 5, comma 5. And then limit as x approaches 1 from the left of f of x is equal to, limit as x approaches 1 from the left of f of x is equal to, 1 from the left is equal to 8, because we are now substituting 1 in this function, which is x plus 7, right? 1 from the left is approaching these functions here, right? These function values until it reaches 8. So we're getting an answer of 8. We can clearly see a jump in these y values. Therefore, limit as x approaches 1 of, limit as x approaches 1 from the left of f of x is not equal to limit as x approaches 1 from the right of f of x. Therefore, f of x is discontinuous at x is equal to 1, and the type of discontinuity, it is a jump discontinuity, right? It's a jump discontinuity. Looking at the next x value where the discontinuity exists is at -4. So at x is equal to -4, you can say, let us use this definition of continuity. Limit as x approaches 4 of f of x is equal to f of, should be -4, f of -4. Now we can see that limit as x approaches -4, whether it is from the left or from the right of f of x. So if I approach 4 from the left, -4 from the left, or -4 from the right, we are reaching the same value, which is 3. So we're getting the same y value, which is 3. So let me just substitute -4 in here. So -4 times half minus half is 2 plus 1, which is 3. So we are getting the value of 3, which is equal to 3. And f of -4 is equal to, f of -4 is equal to 5. See, f of -4 is equal to 5. F of -4 is equal to 5. We can clearly see a jump in value again. So the jump discontinuity, what we can say is, therefore, f of x, therefore limit as x approaches, therefore limit, this is for check for continuity, right? Limit as x approaches -4 of f of x is clearly not equal to f of -4. Therefore, f of x is discontinuous at x is equal to -4, and the type of discontinuity, you can see a jump in value, so a jump discontinuity. Right, I was thinking of a removable discontinuity, but let us look at this. Assuming that this coordinate here, if f of -4 is equal to, if f of -4 wasn't defined, if this was not there, if this part was not there, then could have said, then we can say that at -4, it will be a removable discontinuity. But in this case, it's not removable, it is jump. We can see a jump in y values. Right. Moving on to the next question, which is question 6.2. Right, we have, this was 6 marks and 6.2. Determine A and B if f is differentiable at x is equal to 3. So we are looking at x is equal to 3. What we're saying is at x is equal to 3, it is differentiable. At x is equal to 3 here. So what we know, the rule is if f is differentiable, so looking at 6.2, right, let me just go to a new page. So looking at 6.2, what we know is if f is differentiable, then if f is differentiable at x is equal to a, at x is equal to a, then it is continuous at the same point at x is equal to a. So keeping in mind this result, what we can say that, let us look at the continuity part first. Remember, at x is equal to 3, we are observing at x is equal to 3, right? At x is equal to 3, we have two different functions, which is negative 0.5 x squared plus 6 when we are approaching from the left, and when we are approaching from the right, we are getting this function ax plus b. So I will do differentiability first. Let us look at differentiability. So f prime x, right, is equal to f prime x from the left. So you can say x is equal to 3, right? Says from x is equal to 3, we're looking at from the left and from the right. So what we're looking at, ddx of the function, which is what's happening at 3 from the left, negative 0.5 x squared plus 6, negative 0.5 x squared plus 6, because we're looking at, right, so you can say at x is equal to 3, right, 3 from the left. We're finding the derivative of this function evaluated at 3. Why the derivative of this function? Because it's from differentiability from the left, right? So what is the function? Minus 0.5 x squared plus 6. So minus 0.5 x squared plus 6. Find the derivative of this. We're getting negative x evaluated at 3 from the left, which is equal to minus 3. So to differentiate this, we're getting 2 times. See, if you have to differentiate, 2 times minus 0.5, which is minus 1 x, and then derivative of 6 is 0, so minus x. 3 from the left, we substitute 3, and we get this value, which is minus 3. Now, similarly, we can say f prime x from the right. Now, remember, x value is equal to 3, so we're actually doing 3 from the right, which is ddx of ax plus b at x is equal to 3 from the right. So if I differentiate this function, what we have is a evaluated 3 from the right. There's nothing to substitute into, so it's just equal to a. So from what we know is that differentiability from the left, f prime from the left must be equal to f prime from the right at x is equal to minus 3. Therefore, we can just equate left and right. So a is equal to negative 3. Right, now to find the value of b at 3, what we can say is limit. We can look at continuity because differentiability is done. If f is differentiable at x is equal to a, then it is also continuous. So let us look at the continuity. X approaches 3 from the left of f of x must be equal to limit as x approaches 3 from the right of f of x, which is for continuity. Right. Now, what we can say is limit as x approaches 3 from the left. The left function was negative 0.5 x squared plus 6, negative 0.5 x squared plus 6, and the right function was limit as x approaches 3 from the right of ax plus b. Now we have already solved for the value of a, which is equal to minus 3. So what we can say is substituting, so we just have one unknown left, which is b. Substituting 3 inside this function, that's a x squared, right? Let me just neaten that up. Minus 0.5 x squared So if I substitute 3 inside here, remember this is half and this is 3 squared, which is 9 over 2. So if I just pop my calculator, yes, if you just pop your calculator and see, or let me just solve it, which is 9 over minus 9 over 2, which is minus 4.5 plus 6 should give me 1.5. So we're taking 6 minus 4.5, which is 3 over 2. So what we have here is 3 over 2. Value is 3 over 2. And on this side, 3 from the right, we're substituting 3 times minus 3, which is minus 9 plus b. 1.5 plus 9, which is equal to 10 comma 5. Therefore, b is equal to 21 over 2. Now, if we look at the graph, what we have here is a is minus 3 and b is 3 over 2. If a is minus 3, b is 3 over 2. Let us just check if the solution is correct. So what we're saying is that a is equal to minus 3 and b is equal to 21 over 2. So this equation of this line is y is equal to minus 3x plus, let me just write down 10 comma 5, which is the same as 21 over 2. Now guys, if we find the x-intercepts here, we expect to get 3.5 by looking at this. We can see this line is intersecting between 3 and 4. Let's see. So 10.5 divided by 3, 10.5, and if we divide it by 3, we are getting 3.5. So perfect. So this is your correct solution. So going back, it's good to check your answer. So we have b as 10.5 and the value of a as minus 3, which is the correct solution.